Good morning and welcome to my session, Streamlining Remote Workspaces for Developers. I'm Valentin and I hope that you enjoyed your conference so far, learned a lot of new things, interesting things, things to share with your teams. Today, this morning, after the party from yesterday, and after party for the people that went to the after parties, we will take it a bit slower, learn a little bit about how you can streamline your workflow and workspaces for your developers in some different ways. But first, who am I? I am Valentin. I'm the founder of Spark Development, company in Cluj-Napoca. Actually, it's near Cluj-Napoca, but I will point it to be in Cluj-Napoca. I'm in the field since 2010. I specialize in software development and operations, DevOps, Linux administration, and all that stuff. And I really like working with Linux compared to Windows and also Mac. I enjoy playing games and learning about new bands, new artists, finding new events that I want to go to see different artists, different bands, and helping them grow. Also, I enjoy taking pictures. This one isn't taken for me, but I put it on my page. I will put on my page some pictures that I took around Valencia, beautiful city. Yeah, about Spark Development, we are a studio in Cluj-Napoca. We are a team of 2 currently, but maybe in the future we might grow. We deliver focused and tailored solutions for our customers, ranging in different domains, finance, automotive, insurances, and all that part. Beyond business, we are committed to creating and helping local organizations build their community and try to improve our impact on the social causes locally. So, the agenda for today, some things that we want to discuss, also a QR code, so if you want to participate later in a small, let's say, survey, Q&A that I will have on screen to discuss some questions. Those questions will be focused around various parts of the presentation. So the agenda is focused on what matters for a developer, what developers really need, what we tried for different approaches for development, local environments, cloud, remote desktop, remote environments, and some key points that you can take in your teams to assess what solution works better for you. And in the end, if you want to discuss more about this, feel free to come here, or you can also find me at the Wayfair stand, because yesterday I had also a presentation with Wayfair and I am helping them bring new things and to develop their customers and their partners with their relations with their partners. So, the challenges of remote development. This part is the thing that we tried to investigate and see how we can do things better, because working with teams all around the world proved a challenge, not only for us, but also for our customers. Preparing environments, making sure that the secrets aren't shared with anyone and they aren't lost or they are exposed to the public and be part of security threat. Going to have people use those secrets to do malicious things. Yeah, having different versions of the tools. Working, for example, with one version of OpenEdge, preparing to go to another version of OpenEdge. We had a customer that worked with PHP 5, and they are starting to prepare the migration to PHP 8.4. It's an interesting migration that they are doing, and yeah, having both versions locally, they usually conflict around things. When a developer leaves the team, then they have to clean up their machine. So not in the case of where you have developers hired in your team and they are your employees, but when you work with remote teams, they might keep some source code in their machine, and you do not want that. And some situations where projects are really, really large. Had one project which, let's say the code wasn't a large code base, few hundreds of files. But when you started the environment, all the tooling and all the requirements, databases, additional third-party tools, took around 50 to 60 gigabytes. So it's quite a large project. Okay, so doing the research for the teams that I work with and with our customers, we find out that they need some way of working remotely, to have everything already set up for them, to use Docker, because that way they can spin up new environments, new things, test applications, test tooling for the project. Preferably the machine to be a Unix-based machine, Linux, Mac OS. They are used with the command line, used on how to start up things, to run things. Need to have a database available for them. It can be any kind of database, Progress, Postgres, MySQL, Oracle, Microsoft nowadays being able to be run on Linux, Unix machines. And to have a way to commit their code to a Git repository. Or, yeah, mostly Git repositories nowadays. And what approaches we identified? We split it into three. And the first one is the local development. Here, it's a local classical approach where you have all your tooling and everything installed locally. Works perfect if you don't have internet, or if you have a bad connection, you work locally. When you have a better internet connection or internet connection at all, you go commit your source or do things that need internet. You can develop mobile, desktop applications besides, let's call them web apps, but not only applications that expose an API. You have the flexibility to choose the SDK locally on that machine. I do not want the version 12, I want the version 11 or version 13 in the future. And as I said, it's ideal for desktop and mobile apps. Nowadays, Google tried to do some kind of development for Android-based applications in the browser, but it's just the first step towards it. The disadvantages, hardware upgrades cost. Well, if you have and work on a desktop machine, those upgrades are not that expensive to add to your machine. But if you're using a laptop, nowadays they're trying to solder everything on their machines, on their PCBs, and if I need, instead of 16 gigs, 32 gigs of RAM, or even some better spec hard drive or SSD, I might need to buy a brand new machine. Or in the case of Apple, if you develop iOS, macOS applications, you need a better hardware, you need a better laptop or better mini PC, buy a new one. Tools might have different versions that might clash between them. So there are configurations that do not work okay. If you want to run a specific version, it tries to look in a, let's call it default configuration place, and it will be, okay, I deprecated this, I removed this, why it's still here? I do not know what this configuration parameter is. From this local development part, so everything on your machine, different tooling, there is a possible better solution or better alternative called dev containers. These were, let's say, promoted and created and developed by Microsoft with the help of Visual Studio Code. So if you're using Visual Studio Code, dev containers appear there for you to use them to configure them, to do development inside the container and have only the tools you need, only the source code you need, and everything prepared for you. This is a better approach to the standard one because the same environment or same setup can be easily moved around from your machine to another machine, to a test environment, to a production environment. Same setup, you cannot say anymore, it works on my machine, but on the other machine it doesn't work. But we said that it's a better. Yes, it has consistency. Actually, it has fast onboarding times because you give someone the repository or a file, a JSON file. They run it inside Visual Studio Code. Everything is built for them, set up, all the extensions, all the plugins are there. You have the isolation. My project A doesn't interfere with project B. They can run in parallel and do code in parallel for them. The cons, performance overhead. So dev containers are based and run on Docker. If you want to have a good environment, you have to give Docker enough resources, enough things from your machine for it to run better. You need to have a little bit of Docker experience. The actual developer do not need this part for the Docker experience, but the one who does the setup needs to know some Docker things. Building a Docker file, what to put there, how to configure it, what parameters to use to make it as optimal as possible. Storage space, it's used from your machine. One caveat if you're running dev containers on Windows is that Docker runs in VSL, Windows Subsystem for Linux. That part, even though it's not a virtual machine, it creates some kind of virtual hard disk, which Microsoft, or not Microsoft, the Docker developers set it for 1 terabyte. If your machine doesn't have 1 terabyte, you will be out of luck. If space fills up, it will try to write continuously in that image and doesn't know what to do and will fail and crash very, very bad. Also, you have some tooling lock-in. So you will depend on Docker to do this part, or Kubernetes. Depends on the provider or what you will run in the background. The next approach that we looked, so we started with the local development, then we tried to look on the remote development side. What can we do there? How can we do that? So the usual suspects in this case are remote desktop or VDIs, Amazon Workspace if you want to run everything in cloud, or Azure virtual machines, or it has another name for the Azure, but it's the same thing. It runs Windows and you connect to a similar client like the remote desktop. You have the ability to run Visual Studio Code remotely on another machine. And you have the dev containers that I already presented. You can run them again on a remote machine, not on your local machine. So going with the remote development, the pros can be easily upgraded. I need a better machine with better hardware, better RAM, additional storage, call the IT support. I need this, this, this. They will perform an upgrade if space is available. The same VM can be reused for multiple developers. So I can set up a base machine with all my tooling, clone it for each developer, and apply some specific setup for them. Quick onboarding and decommissioning. Someone comes in, here is the VM, here are your credentials, you enter, do that stuff. The developers leave the team or it's moved to another project, the machine is decommissioned, nothing is on their computer, on their PC. We don't have that security risk anymore. Also, we can provide them with access to a secure environment where we have a larger dev database, where we have some, let's say, sensitive data that is in a test or staging environment produced by our testers, by our stakeholders that enter there some information to test to see if it works like in production. If you do not anonymize your database, and that is a bad habit, if you move from production to the other environment with the same database, there is a security risk. You give developers through this way access to those databases, but try not to move the data from prod to the other environments without doing the anonymization or using the data masking tool. And cons, well, you can upgrade the machine easier, but at the same time you need good servers to do that. You need large data warehouses or warehouses where to have your servers. You require a dedicated system administrator to perform all the tasks on the server, to clean up, to create new VMs, to prepare them, to make the network setup, add new elements. Apple hardware is difficult to virtualize. It's not impossible. Nowadays, they started to improve that part by bringing the virtual machine subsystem and the virtual machine kit. And I do not remember right now the name, but they're trying to improve this part for the virtualization. But still, you cannot install macOS or the server part on non-Apple hardware. So you need Apple hardware, which is expensive, even their Blade server. You need a strong and stable internet. So if you have remote teams, they need to be able to connect to that machine. This is, let's say, once you need a stable connection to your data center or to the server, and at the same time, your developer needs a good internet connection to be able to connect to you. And licensing costs, using Microsoft technology, going with Amazon. You need to pay them some licensing fees for using the servers. If you want to set up your infrastructure for the VDIs, again, it costs. The open source community is starting to grow, but the existing commercial solution, they cost. Now, I said earlier, we used VDIs, we used remote desktop, we used Amazon Workspaces to connect to a virtual desktop, Windows-based. With the start of VSCode, and back, I think, to 2020, 2021, they have some extension called Remote Explorer or Remote Development, where you can install those extensions and the Visual Studio Server on a Linux machine. And from my local machine, a Windows, Linux, Mac, I can connect directly to that Visual Code instance. And in our case, we had a Python-based project where we pre-configured the Linux machine with everything that was needed. MySQL database, a Python environment, Node.js, because the front end was Node.js. The back end was Python, because it had some data scraping in there, some reports to be created, some analytics, and some AI integrations. The Visual Studio Code was pre-configured by me with a set of plugins. Everything that I thought that was needed for that was installed there. We had a bootstrap script that was used to launch the application, because for the front end we used React. We had to open React and then the backend to be able to connect and test our application. And what's the most interesting thing? Visual Studio Code will make a port forwarding for you for the ports that are exposed by the applications. So when you go in the browser, you run localhost and enter localhost and the port, and you see your application. You don't have to know the public IP of that machine. It's still working. Our customer is still using that. I had earlier this week some issues with the connection to the machine, changed one parameter, and the developer was able to reconnect to this machine. Now, these are the classical approaches that we already know. So if you move to the future, to the current way of doing things. It's the cloud development part. And here we have various tools that we can use. Coder, GitPod or ONA, how it's called now, Harness, Firebase Studio, the one created by Google, Eclipse, which is some variant of Visual Studio Code, and the GitHub Workspaces. So if you have your code in GitHub, they can provide you with a Visual Studio Code in browser for your workspace. And to be fair, everything that's here, and it's cloud-based IDE, it's a Visual Studio Code in the backend and in the background. Pros, fast onboarding and standardized tooling and everything, similar to the remote development part. You have environments on demand. Okay, I need a new environment for this project. I open it, run it, develop. When I'm finished, I close it. Everything is gone. The resources are free for everybody to use later for things. And on this way, you only pay for what you use. You can blend on-prem and cloud setups, as we will see in a bit in my demo. You have a better cost visibility and control. So let's say I want to see when my budget exceeds a specific amount. If I go in a cloud and run some VMs, I can set up some alerts and then do some changes. Okay, this month we won't be using the fastest server, we will use a slower server. But yeah, even if I have cost visibility, the cost can scale quickly and with usage. Better machine, higher costs. Requires Kubernetes or Docker knowledge to do this setup. Yes, it is a requirement, but it's not for your developers, it's for the person who does this setup. They only have to do their work. You risk a vendor lock-in. So if you go with a specific tool, and they might change the pricing, they might be bought by another company, you won't be able to export your setup or your configuration from them. High performance clusters needed for large teams. So if you have a team of 50, 100, 200, 1,000 people, you will need either a data center or go to the Amazon, Azure, Google data centers, OVH, Hetzner, or any other provider. Also, for the easier setup of the development environments, you will need Terraform or Ansible knowledge. Why? It's easier to configure that way, and you go with an approach as infrastructure as a service. Code it and run it anywhere. In our case, we are starting to test out Coder, an open source platform that supports self-hosting. So you can put it locally or you can put it in cloud. It's your choice. You can create workspaces anywhere. So if you want to connect your local data center to it, it's easier. You have to put some keys, some setup, and use that one. You can use cloud to deploy virtual machines in cloud that developers can afterwards connect to them through the platform. Fuel Feature Community Edition. You have everything needed. You don't need the paid support, paid version of it. It integrates, in our case, with Microsoft Entra ID for sign-in. But you can also log in with Google, GitHub, AWS. They have lots of plugins and authentication, authorization support. In this case, workspaces are created with Terraform, and they have some templates already available for AWS, Azure, Google, Proxmox, Docker, and so on. And here is a small demo on how to create, in this case, a workspace in AWS. So I fill some parameters, select the resources that I needed, the location, and now the VM is powered up. Some setup is being done in the background. It usually takes around 2 minutes, and what's nice about this platform, if you see here, it has an estimation. Sometimes it's a Windows-like estimation. It says 1 minute, but it's actually 3. But most of the cases, it says 2 minutes, and it's done in less than 1. So right now, it's doing the planning of what is needed to be created in the cloud. And yeah, it starts to apply those things and create the VM, create the networking for the VM, connects everything that it's needed there. And yeah, the workspace is done. And now it starts with the actual workspace creation to set up Visual Studio Code, to set up various, if you put there a repository that you want to clone and install it in that VM. We have it here, everything is done, prepared, and we can click on any of those items and you can see a graph of your execution time. I will come back to this part in a bit. So, start the code server, another tab in the browser, and we have here everything that we need. And in this case, I run a VM, an application locally, which it is exposed by this VM, by this Visual Studio Code. And finally, when I'm done with my work, I stop that VM. Here, intentionally, I clicked several times to trigger an error. And then what it does the reverse thing of the setup, where it starts to uninstall things, remove things, delete things from AWS, and in the end notifies me, okay, everything is done, everything is clean, you can do whatever you want. So, before going further, as I said, here is my example. So, if I go to the workspaces, I have several machines, several environments available based on some templates. Here are the templates where I have the code provisioned to create these workspaces. These are based on AWS. But if you hit the new template, you have Docker containers, Azure VM, DigitalOcean Droplet, Google Cloud, Kubernetes. Or you can create your own templates and upload them here. They have a registry where you can find different modules that can be used, various templates, similar to the ones that I already have in my environment. And I can create a new workspace. This is one created by me, the template file. I can put whatever name I want, so it can be sample 1, 2, 3, 4. In my case, this is not for the cloud environment, but for my on-prem machines, which runs Proxmox, which looks like this, where I have some VMs and Linux containers. I can select how many CPU cores to have to configure the networking, and put 101 and my gateway. I can move to, let's leave it with WebStorm, enter my public key. Select how many gigabytes of RAM to have and perform a quick repository checkout. Create workspace, and it starts with the creation of the workspace. As I said, first it plans the infrastructure to see what it needs, what resources are available, where to run it, how to run it, what to create, and then starts applying those changes. So the workspace was created. Now it waits for the code server to be initialized. And if I come back to my proxmox, I have this second container. And I can hope to wrote the password good. No. And we can do a sudo. No, I do not want to do that. And we can see that, let's say it's clean here. And now it should start with the cloning and everything. So what it's nice from this UI, from this terminal, you can access directly a console. You can have CLI or terminal access to your machine. It started to create the VSCode server, VSCodium, Windsurf server, and my folder. So everything is running. Click on the code server. And I have Visual Studio Code in my browser. And I can go into the framework folder. And run npm install to do installation of this project. You can set up to do whatever you want, whatever you need. So I started it here in browser. I can start it on my local machine. It needs to download some things from the server. Let's see here. So yeah, it fails in this case because I didn't connect to npm with a specific user to download some private packages, which is okay for this demo. I will allow here. And I can open a folder which is on the remote machine. Trust. This is from local. Saved it. And we can see it here. And this is changed in browser. Same thing here. So I said earlier that it uses Terraform. I don't know how many of you have used or worked with Terraform. It's infrastructure as a code. You code it to create your infrastructure, to create your servers. Not the physical servers, but the VMs. And nowadays it's used mostly for the cloud providers to easily maintain them, to have the similar setup for each machine. It has some modules that you can reuse. So it encourages you for code reusability. Here, in my case, the Coder platform has some constructs. So I have to require some providers, Coder, Cloud Init, and Proxmox. It provides with data. So the things that you saw there to be configurable are here, these data parameters. And after you configured everything, you start configuring the providers and the resources that you need. So in this case, I will need a Linux container with specific RAMs, specific network, a password, but because it is on my internal network and the SSH isn't enabled for this container, I can set it to be random strings and I can leave it here. Also for the template that I'm using, because it is based on a template, this container, there I configured to allow SSH connections only from local network and only with certificates. Other setup that will be performed in the background. The Visual Studio Code server setup, where it installs some extensions, sets the color theme, sets the root directory, where to connect, and all that stuff. You can also, if you use JetBrains for web UI, for Python, React, you can also set up here, and the Node.js server and configuration, and some basic information. So this is a template Terraform file that can be reused for whenever and whatever workspace I need. And as I said, I still have the other one in AWS, but I've done some changes on my AWS account, and unfortunately I broken the networking part of AWS, and I'm still waiting for answers from their support on how to fix everything. So yeah, be aware what you do on AWS or Azure, that it will crash your demo or other things. So this is for the cloud development part. The two approaches, local, remote, and cloud. How to choose what's right for you? Well, first of all, identify the type of application you are building. So if you're building a desktop application, then the cloud, it's out of discussion. If you're building an API-based application, then you can use any of these. But if you're working and your team supports it, you can move to the cloud or remote way. Assess the hardware and the budget that you have. So if you already have hardware internally, servers available that can be reused for this, you don't need to buy new hardware. You don't need to go to the cloud. You can go with an on-premise solution. If you already have VDIs, you have Proxmox or any software installed, you can use that one, and do not go and buy something new. Match the needs to your approach. So if you don't need large hardware or your application isn't that big, don't try to go and spend money on things you don't need. Use it later for conferences, coming here, enjoying the party, and all that stuff. And the most important thing, pilot with a small team. So check whatever solution works. You can try different solutions with different small teams, assess with them, discuss with them, and choose afterwards the best for them and the best for your company. And because we are an Open Edge conference, I talked a little bit of Terraform, Node.js, Python, PHP, but not that much about Open Edge. Well, this cloud and all these solutions can apply to Open Edge development. And yeah, lots of extensions are created and are already available in Visual Studio Code, or the different flavors of Visual Studio Code that are available. And you can integrate them with different AI tooling, DeepSeek, OpenAI, Grok, whatever you want. And you have the extensions developed specifically for Open Edge. So try it, give it a try if you have an application that exposes APIs. Go with the approach in the cloud, or not in the cloud, in the browser, to develop with Visual Studio Code in the browser, and do it wherever or whenever you want. One funny thing is that you can use this latest approach to develop on a tablet, because nowadays the iPads start to be more like a Mac than a tablet, or Samsung or other tablets already available. And the key takeaway, you need a secure environment, you need to be consistent, and it needs to be efficient. So not all solutions are best for all use cases. In our use case, it's best for the cloud coder, the cloud-based approach, but for another project, it might be the local environment. Choose wisely and try not to overspend your budget or your money on one solution. And also try to plan and think for the future. If your team will be growing, if you will have a remote team, try to find what's the best for you. Q&A, questions, if you have for me. Yes?
In your experience,
yes.
where is best to set up and configure the database and application storage?
I would say the database I would configure it in a central part available for everyone, not only for you locally or for that specific machine, because it will be much easier to access data and provision it with data in a single place instead of multiple places. And if you want to have a good database for development, you might have gigs of data there. So 1 gig here and 1 gig here and 1 gig here grows the workspaces or the machines really, really large. For the application part, application server, I would say to have it locally on your machine. That way, you can fastly check the changes that you've made to see them running firstly on your local machine, and then you can push it to the other environments. If you have, let's say, besides your local machine, you have the dev environment, the test environment, and the production. When everything is ready, you can push it to the dev, and the other devs can test your changes. So not to test them only locally. Any other questions for me that you have? And I said earlier about a survey. Menti. So I will show once again those QR code. So if you scan this QR code, it will take you to that survey that I showed you one moment ago. And I can do something here. to have it also on screen. This one can go here. So we have some questions. What kind of applications are you developing? Desktop, mobile, or web application? Let's see. Okay, so the battle is between desktop and web. So as I said earlier, based on the kind of application you are developing, you can choose between those things, those approaches. Next, what technology are you using? And here, I'm hoping it will be OpenEdge for most of the people. And I think those 3 persons with the web will have another technology beside. So by the way it's moving, it means that a lot of OpenEdge answers are added. So yeah, Flutter, HTML, OpenEdge in Java. So for Flutter, you are doing web, mobile, or desktop. If you're using the desktop version, that's good. If you're using the mobile version, that's even better because you will have everything for all platforms, all 2 platforms, Android and iOS. Python, .NET, Vue.js, quite some technologies. And in the end, how many developers are in your team? So, yeah. Yeah, as I said, based on the number of developers, do a small team assessment of the solution, and then go to the rest of the team. And here, the Q&A. If you have questions to me, you can add them there, and I can answer them later. Okay, I'll come back to my presentation. You can contact me on that QR code if you scan it, or you can send me an email here, or on our social email and social platforms, Instagram, Facebook, X, or Twitter, Threads, GitHub, GitLab. You can use the same handle. If you have no other questions, thank you for attending the session, and I hope to see you next year in Amsterdam.